Let's take a look at some additional examples on simplifying radicals, like number 4, where we said during class that we should multiply by the conjugate of the denominator, which is 2 plus the square root of 3, and multiply the numerator by that binomial as well. I then just wrote it as one fraction, and distributing in the numerator gives us 10 plus 5 square root of 3, whereas in the denominator we get 4 plus 2 square root of 3 minus 2 root 3 minus the square root of 9, which is 3. Then we see that these middle two terms really cancel each other out, which is why using that conjugate binomial was helpful, as we now end up with a rational number in the denominator, as 4 minus 3 is just 1. So altogether, this expression simplifies to 10 plus 5 square root of 3. And in this next example, we want to simplify this expression as much as possible. So we'll split up the numerator and denominator, taking the cube root of each. If you want to go ahead and simplify the numerator, I want to find a perfect cube factor of 135, which is 27, and the cube root of 27 is 3. So I'll divide 4 by 3, and 3 goes into 4 one time with a remainder of 1. And this number tells us how many a's to bring outside of the radical, and this other tells us how many to leave under the radical. But using that same method, we see that we'll bring out 1b, and therefore a 5 and an a remain under the radical. So now we're going to try to determine what we should multiply the denominator by in order to end up with perfect cubes in the radicand. And so I know that 8 is a perfect cube, and 4 times 2 is 8. C cubed is a perfect cube, and we already have one factor of c. So I need 2 more. And whatever we multiply the denominator by, we'll have to repeat it in the numerator. Multiplying those numerators together, we get 3 times a times b, or 3ab, times the cube root of 5 times 2, or 10, a c squared, divided by the cube root of 8c cubed. And finally, the cube root of 8 is 2, and the cube root of c cubed is c. And I also wanted to take a few minutes to talk about rational exponents. For instance, I can rewrite the square root of 9 as 9 to the 1/2 power, which still simplifies to 3. We could write a cube root, like cube root of 64, as 64 to the 1/3 power, which is 4. But if we're given a number like this, 125 to the 2/3, and we wanted to evaluate this expression, we can use our properties of exponents to kind of go backwards and break up this 2/3 power as raising a power to a power, or raising to the 1/3 power and then to the 2nd power. Since 125 to the 1/3 is the cube root of 125, which is 5, and then 5 squared is 25.